And I believe this comes from, there's a similar question like to this in WebWork, or at least there was at one point, or it comes out of the textbook. I'm not sure which one it is, but find a complex number such that its square equals -9 minus 40i. So what's going on here is that we have x, this value we're looking for. It's going to be able to be written in a plus bi form. And when I square it, I end up getting -9 minus 40i. That's the other thing that some students kind of like, still have to get used to. Because we're talking about complex numbers, having negatives involved with a squaring is not unheard of. It's not something that, you have to be concerned about necessarily, or you have to say it's not going to happen this way. It can't, because, well, it can now because we're talking about complex numbers. So essentially, what I'm looking for is if I want to express x squared in terms of a plus bi, that's what I would do. And here's what I'm doing here. I FOILed it out, recognizing that b squared times I squared would be b squared times -1. So if I simplify and regroup, having the two real parts only grouped together and the complex number parts grouped together, I would end up with a squared minus b squared plus 2abi. Which means that -9 minus 40i has to equal that same thing. As I look at what I have on the left and right, the a squared minus b squared should be the real part of the complex number, and we know that the real part is -9. So I know that a squared minus b squared should equal -9. And likewise, the 2ab in front of the I should be the same thing as the -40 in front of the I. It should be your imaginary part. So 2ab should equal -40. What I have here is a system of two equations with two unknown values. And if I have two equations with two unknown values, I should be able to solve that system for both variables. I just have to go through a process that will allow me to do so. So 2ab, I'm going to turn around a little bit and say, like, essentially I'm going to multiply both sides by 2a and get that b equals -20 divided by a. And I'm going to substitute back into the first equation, so where I'm going to have a squared minus -20 over a squared, and that's going to equal -9. So a squared minus 400 over a squared is going to equal -9. And I'm going to try to solve this thing out. I'm going to multiply both sides by a squared. I get a to the fourth minus 9a squared minus 400 equals 0. It is a fourth degree equation, but since it only has three terms set equal to 0, and I have the second term having an exponent that's half the degree of the first terms, and I only have three terms, one with a constant term, that's a quadratic format. So that means I could use factoring or the quadratic formula or whatever have you to find out what a is here. Here I did choose factoring. A squared minus 16 would equal a squared plus 25, which means that either a squared minus 16 would have to equal 0 or a squared plus 25 would have to equal 0. If a squared equals 16, a would be either positive or -4. If a squared was -25, a would be either positive or -5i. Now I have to remember that a represents part of a complex number. It's the real portion of the complex number. Along with that, a also has to itself be a real number. So a being 5i or -5i is excluded because a has to be a real number. That's how we define a complex number. So if a equals 4, knowing that b equaled -20 over a from back over here, then b would equal -5, and if a equaled -4, b would equal +5. So actually I do get two answers. It's not just a complex number, there's actually two of them. X could equal 4 minus 5i, or x could equal -4 plus 5i. And if I squared either one of those, I would get -9 minus 40i.